I have just arrived here in Cheddar Gorge. I am very, very excited because I have not been here since I was pretty much a kid. It is absolutely glorious looking at all these rocks here. I'm looking forward to finding a bit more.
Cheddar Gorge has a list of things it's famous for, from the views themselves to the amazing caves underneath with crystals and caverns. Which, let's not forget, have housed cheese, because yes, this is where cheddar cheese gets its name from, which obviously I had to sample. I'm a geologist and I'm going to take you on a deep dive of the science below the surface at Cheddar Gorge. Yes, that's 2 puns on a trot, and no, I won't be stopping.
So today we are climbing up here. Most of the show caves entrances are in this little area here. But we're going to climb up to get a nice view of the whole of the gorge, so I can explain a little bit about how it got here in the first place. So, just different steps to go.
The steps alone aren't for the faint of heart. In fact, there's 274 just in this spot, and I'm not even going to think about how it inclines after this.
It's me in the knees, I can confirm.
Just be thankful you get to watch this from a screen, but it does give you an idea of just how significant the topography, or the incline, is compared to the surrounding area. From the lowest point by the car park to the tallest point at the top of the hill, you're talking over a 230 metre elevation gain. But you can see from the contour map here that these cliffs are huge. That said, side note, I noticed even the cafe had a contour map as a floor, which I absolutely love and want one. Anyway.
So, how did Cheddar Gorge get here? Well, first I need to take you back to the Carboniferous period. Back then, this whole area would have been a shallow tropical sea, kind of like the modern Caribbean. You would have had nice, warm, clear water, corals forming massive reefs with lots of shelly creatures all milling about. So this area was glorious, hot, warm, and it sustained in this sort of like continental shelf area, so just out from land, for millions and millions of years. In fact, it's quite odd that it managed to maintain that sort of environment for quite so long. The thickness of the rock unit itself here, this Carboniferous limestone, is actually 1 kilometre here at Cheddar Gorge. So this is a massive extent of limestone. During the next Earth era, called the Permian, that's when all of this starts getting forced up by the formation of everyone's favourite supercontinent, Pangaea. So at this point, all the tectonic forces were pushing plates together to form these massive fold structures. And here, we've got a series of what we call pericline.
What is a pericline, I hear you ask? Basically, it's a dome, and this is where the rock has been squashed a little bit in a couple of directions, so it closes off. Easily done when you're stuck in the middle of a mountain building event. So picture this on a landscape scale. You've got 4 of these rock domes in the Mendips that we can see on the maps. Cheddar is on the outskirts of one of these domes, so all of the rocks in the area tend to dip about 20 degrees to the south, which is why when you look in the cliffs, they're not all just like flat and horizontal.
As these environments continued to develop, the tops of these domes got eroded away, exposing the older sandstones underneath. Now these were Devonian sandstones, and they're like bright red. So they created these little hills with like Carboniferous limestone, a little bit of a red top, and Carboniferous limestone going down again. Fast forwarding into the next time period again, we've got the Triassic. So at this point, all of these hills, everything starts eroding into the valleys, and we start creating a plateau. These limestones and sandstones that were eroding off of the hills cemented together in the valleys with calcium carbonate and magnesium carbonate to become what we call a dolomitic conglomerate, which is a hell of a mouthful, and I did just have to say that 3 times off camera. So now, just getting a little bit more modern again, we're into the Jurassic period. Again, this all got submerged, it became a nice warm ocean, and all loads of carbonate sediments started forming again. But thanks to all sorts of erosion over time, these are now gone and we can no longer see them. Into the modern day, or what I like to call the last million years, then this whole of Britain is captured under Ice Age conditions. So the ice sheet at that point would have reached about... So the ice sheet comes down that far, with everything just south of being periglacial, which is really frozen ground, very cold conditions, and lots of meltwater powering through. It's that meltwater that caused this gorge. So, you know, lots of little Ice Age periods, lots of meltwater pushing through repeatedly. At the time of these Ice Age periods, a lot of the caves that you see now would have been blocked with ice and mud.
Each time those meltwaters started again, they had to go somewhere. Which leads me on to the formation of the caves.
So this here today is Gough's cave. This is the biggest of the show caves they've got here. I'm going to go in for a bit of a wander and show us what we can find here in terms of geology, in terms of a little bit of archaeology, and even what you can find in the soils of the cave floor. Let's go have a look.
And I was going to cut the footage here, but you deserve to see my happy dance.
This is very atmospheric going into here as we walk into the cave and the underground riverbed. You can't help but walk around and notice there's lots of these sort of cavernous areas and different textures on the walls. Now, all of these can tell us different things about how water has flowed over time.
Now, in theory, rainwater should dissolve the first limestone it hits when it falls from the sky. But in reality, the rainwater can't dissolve the limestone quick enough at the surface, so it begins to descend through any cracks in the rock before it gets fully saturated. Therefore, it still has the capacity to dissolve more limestone as it gets underground, widening each of these cracks as it goes. Now, fun fact, the faster the water flows, the more the limestone is dissolved. So, when the cave is wide enough, the water quickly becomes turbulent and then enlarges it and becomes quicker, and so on and so forth. The relatively fast-flowing water can develop a system with channels and tributaries as it powers through, spurred on by all these quickly melting glaciers. In fact, in some kind of way, it almost looks like a surface water river, but underground and 3D.
This cavernous bit here, for example, is fantastic. So, the larger sort of circular bit, that shows us when water was flowing through at quite a slow rate and it was slowly winnowing it away in like little, almost like little whirlpools. Then it's got this other texture underneath it of more little tiny pieces, and that shows as the water was getting a little bit faster and it was all swirling around. So this really helps us picture that the water at some point would have been all the way up to the ceiling and it would have been flowing quite fast during flood events. So I'm going to take you along a little bit further and I'm going to show you some of the other really cool features that helps us see how the water has flowed through this place. Features like this happens when water is flowing through and it's all churning up and it exploits a fracture plane that's going vertical. So here you can see as it's exploited one plane, but it's all curved around the edges as all this water's swirled around. But my favourite feature is up over here, which up there. So you've got vertical lines coming down rather than little circle bits at this point. Picture a beach. Picture when you see waves washing in on a shoreline and that ripples that you get in the sand. That is exactly what you're seeing here. So these ripples are sort of indicating more of a flow through the cave. So it's hard to tell from down here, but the chances are they're asymmetrical, and that would tell us exactly which way the water's flowing. Now, I'm willing to bet it was towards the mouth of the cave, but I wouldn't want to assume. But then as you walk around just a tiny bit more, you can see that we lose that straight edge part and it starts becoming almost like beaten copper. That is starting to show us when it's becoming these little winnowy whirlpools again. You can really get an idea of how the water's moving and flowing through this cave just by looking at the ripples on the ceiling.
But the ceiling isn't the only thing holding clues. In fact, the floor does too.
Okay, so where I'm stood here actually gives you an idea of the proper floor of the cave. So unlike the concreted section where it's all been man-made, this is just natural soil and rock. And all of this sediment that fills up the cave floor would have been washed in through lots and lots of flood events. Now it's really hard to know exactly when these flood events were and exactly how much water came through, but we can get an idea of relative sediment layers by sort of seeing how thick one colour of deposit is and things like that, or whether there's lots of gravelly bits in one layer, and kind of get an idea of the different events at least. So I must admit, I don't know which one stuff like this would attach to, and in fact it could just as easily be where workmen have piled a bit up here, but it does give you an idea that it's not the concrete perfect floor that you walk in on.
There have been extensive mapping and studies of this floor, partially for geological interest to understand how the floods have happened, e.g. those conglomerates would have been super high energy to push around big pebbles, whereas the cave earth would have been finer, smaller little floods. But also for archaeological interest. It was in one of these layers that the Cheddar Man was discovered. Cheddar Man is the 10,000-year-old remains of a Mesolithic hunter-gatherer discovered in this cave. He's one of the oldest complete skeletons found in Britain. Scientists at the Natural History Museum and UCL partnered up to analyse his DNA and worked out that this is roughly what he would have looked like, coupled with all the flint tools also found in the sediments of the cave. These caves could provide an amazing insight into the post-glacial history of humans in Britain. I'm not going to dwell on the archaeological aspects because I get out of my depth really quickly, but there was a whole show on it a few years ago on Channel 4 if you want to learn a little bit more. Meanwhile, I want to talk to you a little bit more about some of the formations we see in the cave, because you can't come to Cheddar and not see the incredible stalactites and stalagmites.
So this here is a really cool one of the little columns, and you can see it completely joins the roof to the floor. Very cool.
To better explain how they form, I'm going to take you out of Gough's cave and into the neighbouring Cox's cave. I filmed less in here because it's set up as an immersive experience, which I absolutely loved and could have stayed in for ages. But there was some lovely tinkly music, so I didn't do much talking while I was in there. Anyway, the main reason I'm taking you here is they've set up the lighting and the water in this cave to really highlight the stalactites, stalagmites, etc. So I need you to picture that rainwater that had been seeping through the rocks. Now we're not in turbid floods like they were in the Ice Ages. Water can get saturated in minerals as it moves through the rock. This water drips down from the cave ceiling, depositing calcium carbonate and other minerals as it evaporates. If it builds up from the floor, it's a stalagmite because it might reach the roof one day, and if it drips from the top, it's a stalactite because it's holding on tight. Not literally the reason they've been named, but a good way to remember it. That said, you can see how it exploits natural fractures in the rock. So these features can start to form in like curtains or certain planes. This process is so slow, they often grow less than a millimetre a year, so to see formations like this is thousands of years in the making. But let me take you back to Gough's cave, because it's not just sticks like this that they form into.
So this feature here is called the fonts. So this is where it's really, really steep in the caves. As the water is funneling on through, it creates like a series of steps and waterfalls. And as the calcium carbonate comes out of the water, it precipitates. It's almost like a little stepped feature with big hollows of water in between.
And I'm just going to go really quiet for a moment so that you can hear this. But I'm assuming for safety it can't fall over the floor, so it does drain away. Because the water is constant, it's a proper little river called the River Yo, and it exits out here at what they call Cheddar Rising. But it's alright, I'll get back in my cave, because there's plenty more features to see here still. Because with the fonts, you were seeing flowstone, but it doesn't have to be just in ponds. It could be huge expanses like this. Or this. In fact, the more you look, the more you can see it's just the replication of where water's flowing. This bit I think was one of the most enchanting because it just looks like a river's been frozen. These little broken slabs here, they think these might have related to a earthquake about 700 years ago. Whilst we don't think of the UK being that seismically active, it has had some big events in the past, and in fact this one was really well known for knocking down St Michael's Church, which was atop Glastonbury Tor. Actually, not very far from here at all, so it does stand to reason it could be the same event. So they've broken off at that point. So I've spoken a lot about what happens if the water's flowing, but what happens if it gets trapped in an area and nucleates around a point?
Right, so this bit's really cool. Can you see all of these jagged, straight liney bits and all the way to the back of here? This is a little hollow that's weathered out, and all of this is pure calcite crystals. So I can tell it's calcite because I can see the shape of the crystal. It's almost sort of slightly squared off in places. So something like quartz would be more pointed and sort of almost more hexagonal, whereas calcite always forms in these beautiful little squared off features when it has room to grow. And there's another bit down here as well. Again, you can see these beautiful squared off sections. Oh, look, there's actually dogtooth calcite back there. Oh, that's really nuts. That's really, really cool. So occasionally, when calcite has complete room to grow, you will get dogtooth calcite, and that's that there. Beautiful. The red stuff on the surface is just this like sort of cave clay, and that will have all just washed in on flood events.
You don't often see calcite crystals quite like this, so I'm not going to draw too much attention to exactly where it was. as I also noted they had no lights on it, so you'll just have to keep your eyes peeled should you ever end up here. But that doesn't mean there aren't other fun details to see.
Okay, so this is a really fun thing. Can you see here? There's some little coins in the roof. Well, this was actually a little invention that the workers did when they were originally sort of carving this place out and putting some flooring in. Because when they could see cracks, like that quite nasty one there, they wanted to make sure that it wasn't going to widen and fall on their heads, basically. So they would put coins in those little gaps, and if they heard the coin fall out, they knew that the crack was widening, and therefore it was time to get out pretty pronto. I just think that's really good fun.
The caves have been explored for a long time, so there's a lot of evidence of how humans have interacted and shaped the natural cave. But sometimes that's been about more than just rocks or shelter.
Now, I cannot come to Cheddar and not talk about cheese. So, as you might have noticed by the name Cheddar, this is originally where cheddar cheese comes from, and they used to age the cheese in the caves here. And in fact, they still do. Do you want to have a look? Look at all that cheese. So, they age the cheddar here because the cave provides perfect levels of coolness and humidity for the flavour to mature. And just look at the amount of cheese that is there.
The longer it's matured, the more concentrated the flavour, and some here gets concentrated for up to 30 months. The cave's aromas can get into the porous cheese over time, giving it sort of earthy, nutty tangs that are just And there's been references to the cheese of Cheddar here since the 12th century.
They come to Cheddar Gorge just for the excuse to eat some cheese? Maybe. We couldn't possibly know.
But we do know really, don't we? So, fun fact, I actually used to work for a cheese shop, so I am quite a fan of cheese. And when I saw this cafe specialises in cheese and cider, I'm sold.
I think if I died and went to heaven, this would be it. I've got my, apparently, Firking Strong scrumpy cider right here.
Firking strong.
I've got my rocks, and I'm waiting on some cheese scones to arrive at a caged over cheddar. I can't go wrong. I really can't. Actually, that's really nice.
And is it Firking strong?
It's quite fucking strong, but not too bad. Not too bad. We can handle it.
Now I'll speed this up slightly, but this is a cheese scone with a whole pile of cave-aged cheddar and some nice onion chutney. And it was served warm.
Actually, that's amazing. That is really good. You need to try a bit. Generally, cut the pan, you need to try a bit while it's still warm.
Although my cameraman was quite happy with his own meal.
Look at that gooey cheese. Oh no, it's going to drip out.
No.
I also bought some to go because it was just awesome. I'm actually planning to do another whole video on the geology of food and drink one day, so might have to eat more cheese that day too. Refreshed from a little bit of food and drink and a catch up with my old mate Wallace, it's now time to go and have a proper look at the rock, because we've looked at what it's become or what it's carved into.
Quickly, there are some fossils, but I've got to keep running.
But not what it's actually made of itself, because with all the calcite deposits, it's quite hard to show you that underground. It's time to take a closer look outside.
As you're walking along these paths on the top of the cliff, you can see all the rocks sticking out. When you look closely, in amongst these black limestones, you've got white stuff sticking out. That's calcite preserving fossils. Not all of them, I must admit. Some of them are just veins. But like in here, and as we go along, that's actually possibly a little bit of a coral or a crinoid or something. Probably a crinoid, actually. Looks more crinoidal. And then you go along. Oh, there's a couple of good shells there. So it's really painting this picture of the fact that this was a sea floor.
The fossils you see depend on where you are too. So I went down into the gorge itself to have a look.
Okay, so where I am on this surface here, in the rock, there's all these like tubey looking bits. So there's some there, there's another couple up there. I'm kind of sitting on a few here. These are all actually bits of fossilised coral. This really helps us picture this like reef shelf environment where it was all nice, warm, shallow water. I'll get you to come up and have a bit of a closer look. Now, whilst I'm aware they're not the prettiest corals in the world, you'll have to bear with them because you've got to remember, these have undergone some major tectonic forces. So, you know, if I was smashed about by a few tectonic plates, I would probably not be looking my best either.
Now, I was talking to you from this bench here, but I'm going to go up towards the rocks. You can see have tumbled down. Why have they tumbled here and nowhere else? Well, what you're looking at here is actually an old quarry.
Now, obviously, why did they start quarrying in a natural area? Well, the limestone was really useful to people back in the day, and when you had a gorge cutting through, it created a lovely surface for you to just start hacking at to get your quarry stone out. But unfortunately, they kind of went a little bit wrong. So all of the rocks are roughly dipping this way. You can see the surface that I'm stood on is sort of down at this angle. So if I take a chunk of rock here, it's naturally going to slide out that way. And unfortunately, that is exactly what happened on the quarry over here. So there was quite a big landslide in the early 1900s, and this ended up eventually leading to the closure of the quarry here. So cross-cutting this gorge in lots of different places are something called faults. Now, this is where one rock moves relative to the other rock. This is generally caused by really large tectonic pressures, like that, you know, smashing up of Pangaea that I mentioned earlier. So I know that there is some faults going through this quarry. I haven't got time to look hard to find where they are, but I did read online that sometimes they can be tied in with where this sort of red staining is. So that's possibly due to the fact it was happening during the Triassic and it was pulling up some of that red sandy stuff at the same time. I don't want to commit too hard to that though, because I've not got time to go in and investigate and say exactly where they were. But worth knowing that there is lots of this big scale movement happening during that time period. Right, you're on first person point of view now because I've got to do some scrambling.
I'll save you the audio where I was heavy breathing, but generally I was trying to describe as I walked that we were going up through different rock units and that some of the corals that I was starting to spot were looking a little bit different.
I do not recommend this route to anybody other than those who are capable of doing such a route. There is obviously always the potential of rockfall when you're in places like this, so just go careful. Yes, look at these. Nice cross sections through some coral here. In fact, that might even be a little bit of shell going on there as well. You can really see that sort of structure inside the coral. That's awesome. Found some really cute bits in the rubble pile. You can see nice little cross sections through the corals. They are really cute. Got a whole blinking reef here. Look at them all. Everywhere I look, all these little black bits are little bits of coral. So then when you picture that multiplied up by that cliff, that was a long, long time of a sustained period of this amazing coral reef and warm, shallow seas.
To me, that's one of the things that's really enchanting with Cheddar Gorge. It's not just the modern gorge and the caves that everyone thinks of, it's this fascinating time slice through history itself.
That brings me to the end of what I've got time for today, but I absolutely need to get back here because there is so much in this gorge of interest, and I'm actually really tempted to go and have a go at the caving experience at some point as well. But hope you've enjoyed it. Please feel free to look at my other videos, and I'll see you next time.